Okay, this is block 2 from topic 1 using ratios. First thing we're going to look at is my cute little puppy. And I have the same picture on my phone. Do they seem any different?
Yes.
No.
No. It's because I can't sleep.
Okay. Do you think these pictures are proportional?
Yes.
It doesn't look like I cropped my puppy at all.
No.
Okay. So, how are the lengths and the widths of one photo related to the length and the width of the other photo? They are proportional. You know when you're cropping pictures and you can drag it from a corner? That keeps things proportional when I drag from a corner. But when you start dragging from one edge, is it proportional anymore? No. Or drag from one edge, it's not proportional anymore. Got a little midget dog. Okay? Let's get my dog back to normal. So, the corners are nice on pictures because they keep things proportional. So I never mess him up. Cute little fella.
Is that your dog?
No, he's a sweet boy. Okay. Now I lost my train of thought. Looked at my puppy and then I got all distracted. Alright. So we have the same chickadee from Friday, and she's on her computer again, and we're going to see what she's working on her computer now. She's got a giraffe picture this time. She's working with the whip. All right, what did she do to the picture? She made the picture larger.
And she multiplied them by 3.
She multiplied it by 3. What are they calling that number of the 3? Scale factor. Because they multiplied both sides by 3, that is my scale factor. Scale factor keeps things proportional. Alright, and just probably, the picture got bigger, right? It didn't get smaller?
No.
Alright, just take note of that. Okay, let's take... Oh, another cute little puppy.
Is that yours?
No. But it's the same kind of dog, though, isn't it? So,
It's
wrong.
It
It
is.
is.
Now look at the mom.
It's just
One's your dog, one's mine.
the same type of dog.
It looks like
Okay. It says, he wants to make different sizes of the photo. The original photo is 2 inches by 3 inches. Can you use scale factor to solve the puzzle? Alright. So this looks like your chart on your page. They're giving you some scale factors, and they want to find the new dimensions. Well, let's refresh our memory. Here's a scale factor. Here's a width and length. So I'm going to have to multiply 2 times 2/3. How do I go about multiplying a whole number times a fraction? I can put it under 1. Sometimes I just pretend, I just go whole number times top. What is 2 times 2? 4. Can 4 divide by 3 evenly?
Yes.
No.
So you have 4/3. So there would be my fraction. So I want you with your table group, try and finish the chart and we will test the answers. Yes, right on your paper. You have about a minute to finish. Hey, focus back over up here. Well, 2/3 times 2. We already found that answer. So I'm going to drag that guy here. Well, what is 3 times 2?
6.
Can 6 divide by 3 evenly?
Yes.
So what? 2. I'm going to drag 2 here. I got 2 times 3. What is that?
2.
Can 6 divide by 2 evenly? What do I get there?
3.
3. Okay. 3 times 3 is
9.
can 9 divide by 2 evenly? So what do I get? 9 over 2. That extra topping is done. 3.5 times 2 gives me what?
7.
7 whole. And then 3 times 3.5.
10.1.
10.5. And we'll submit and see that we are very good. We're not too bad at this. Okay, this. Freddie, we're waiting on you. A proportion is a statement of equality between two ratios. Here are some examples. This 2 to 3 was the same thing as 4/3 to 2. They're equivalent ratios. And it was also equivalent to 7 to 10.5. Even though it looks funny, they're still equivalent ratios. So now we need to go to our problem in our book to fill in the true definition of a proportion. And it's a statement of equality between two ratios. That is number 2 in your book. I don't know where my little recorder guy went. And I don't remember how to stop recording.
Oh, we'll be here all day.
So this video is gonna
Yeah,
be like,
I'm just gonna wait till the end though and just save it. I don't remember what key was. I don't remember what key was the pause button though. I know escape is gonna stop it. But so sorry, fellow YouTubers.
it's gonna be like 15.
You know you can edit it out.
Yes, you
Yeah,
can.
that's too much work.
I'm gonna edit it out and then
Hey, your sentence already finished?
it's a whole I'll put you on. Hey, don't keep my mom. I always started.
Moving on.
I'll push you back to 8.
Anyone still using this? Hope not, because I'm moving on. So, they give me on this page a whole lot of writing, and I'm going to sum all that up for you instead of sitting here reading it. So I have a table here, and then I have an equivalent fraction here. What is similar in the table and in the fraction? Raise your hand. Something is similar between the table and the fractions down below. What is similar? What you got? She can't hear. Say it again. So basically the same process. What you got? They're both. Oh, they both reduce down to 1/2. They're equivalent to 1/2. Brady, what you got?
It's the same thing.
It's the same thing. Brady said. Just flipped around. Okay. Did they multiply both on the table by 2?
Yes.
What about in the fraction?
Yes.
Okay. So both processes are the same. I can use it in fraction form or I can look at it as a table. So basically all this words off to the side, all it's saying is sometimes writing it as a fraction makes life easier for us because we already know how to work with fractions. Because if I solve this fraction 1/2, if I solve the fraction 4/8, we already know that that is 1/2, right? We automatically think that. So all of this is saying is you don't have to use ratio. You don't have to use fractions, but fractions make life easier. One last thing I want to point out on here. Your homeworks or problems might ask you to write things in fraction notation. All fraction notation is basically this. 2 fractions that equal to each other. Or this equivalent fraction section, that's fraction notation. So fraction notation is actually just writing fractions. Oh, cool. We are going back. We're looking at another puppy. It's actually the same puppy. On problem number 3, it's the same puppy. And this time, we're wanting to make proportions out of these options only. Okay, so these aren't written in your book, correct? My green? I want you to come up with as many equivalent fractions as you can using those numbers. You can work with the people at your table. I want a ton of equivalent fractions. So come up with as many as you can. There are lots of them. You have to use my green numbers on the board. Okay, we got one person testing their fraction. 12/18. He's gonna hit submit and see if he's good. Good job. All right, you got that one. Someone in this room has another fraction. All right, we got a 6/9 is equivalent. 3/6. Boys, my microphone can't hear everybody when you're talking. If I call on you, you're talking. Did we do 8/12? Yes. All right, so we are moving on. So, a couple recap questions. It says, what is equivalent ratio in ratio language? Well,
Fix it.
Jonathan, what ratio did you put in a minute ago when you had the keyboard? 12/18. Ratio language is where you're actually writing it out with the word. So, 12 inches to 18 inches. That's ratio language. So if a problem asks for ratio language, you have to write the word. What other words could I have used instead of 2?
The dot.
Word. For every. Okay? What does that tell you about the length and the width of the picture? So if I have 12 inches to 18 inches, what does that tell me about the width? It's 12 inches. What is the height? 18 inches. This class is going to need a new speaker. If you could use any numbers, what are the other ratios that will work? We just entered a ton of those. So we are moving on. I'm going to see if I go to the slide or if I go to this one. We go to this one. So, you haven't thought to this point, so now we got to think. Do ratios have to be written as fractions?
No, they don't.
They do not. Why do we sometimes write them as fractions? Because it's kind of easier for us. What does each part of a fraction represent in the puppy picture? So I had a fraction of 2/3. What does the numerator represent, Brody? Brady? Yes. What did that represent?
The top of the fraction or the first.
In the picture. What did it represent? The inches of what?
The base. Or is it the width?
The width. What did the denominator represent?
The length.
The length. So are fractions and ratios the same thing?
Yes.
And
no.
Fractions are a number that can be brought to a decimal. Ratios stay as a fraction because we never look at ratios as a decimal. Not really. So we talked about enlarging a picture. How do you think we would shrink a picture? Mathematically. I called on one person. Divide. Any other method of subtract? How could you multiply? Negative numbers. Multiplied by a fraction. Okay, well let's actually take a look at this. So I have this fella in a nice little bow tie. And what does this scale factor look like it's doing here? I'm getting my book. What does it look like we're going to be dealing with? Fractions. Okay? So, here was a 4 by 6. scale factor was 1, meaning I multiplied the width by 1 and the length by 1. Did it change it any?
No.
No. So when I slide this to 3/4, what do you think is going to happen?
It's just getting large and it'll get smaller.
It's going to be multiplied by 3/4 and get smaller. So my new scale factor, this is in your book, my new scale factor right now is 3/4. So what is 4 times 3?
12.
Can 12 divide by 4 evenly?
Yes.
So what is my new width?
3.
3. 6 times 3 gives me,
18.
can 18 divide by 14 evenly?
No.
No, but it could be reduced. Let's see what it, I did times, where did I get 14? I don't think I got 14, did I?
Yeah, you
Oh,
said 14.
I meant 16, huh?
Oh.
18, yeah. 18 over 4 reduces to 9/2. So there's my new dimension. What's going to happen when I go to 1/2? Smaller or larger? Smaller. So what's my new scale factor for this one?
1/2.
1/2. Well, what's half of 4? 2. What's half of 6? 3. So my new scale factor is 1/2. Multiply both by 1/2. I have my new dimensions. Then our last one is 1/4. Getting smaller. What's 4 times 1?
1.
Divided by 4 is
1.
1. So 1 is my new width. 6 times 1 is
6.
divided by 4. Can it divide by 4 evenly?
Oh, whoa. Where did I find it?
We leave it as a fraction. What happens when I go to 0? It's gone away.
Yay.
So between what numbers were we working with?
0 and 1.
0 and 1. I was working with numbers between 0 and 1. That is how images are getting smaller. The scale factor is between 0 and 1. Are these images still proportional even though I shrunk them? Yes, they are. Alright, so you need 2 sticky notes. We're going to recap some things.
What is this magic?
Two, put them anywhere on this page. Write effects of scale factor. Anywhere on page 6, page 6 anywhere. One of your sticky notes is going to say effects of scale factor. And what happened when numbers, what is this symbol? When numbers are greater than 1, what happened to the image? When we multiplied numbers, it gets larger. Makes it larger. Then numbers that were smaller than 1, what happened? Got smaller. And we really didn't talk about the middle one. Maybe we're smart enough to know it. When we multiplied numbers that was equal to 1, the image stayed the same size. Very smart. That is your first sticky note. Your second sticky note is up here on the board. Fraction notation would look like this, and ratio language would look like this, or it might have the word for every. That is your second sticky. On the marker board, the black writing.
Oh, now we have 11. Yeah, 11 girls and 23 boys. No, it's not.
No, it is. I have 34.
20 boys.
I have 34 in there.
There's 11 girls and 23 boys.
Page 2 many boys.
You wanted the other one?
Yeah. It is. Most of the girls are in this hour.
Yeah. She said they had a smaller. Which hour do you not like? Third hour.
And I'm recording.
So she didn't have a third hour.
All right, so tomorrow I'm checking Friday's problem 4 through 6, and today's 4 and 5, and you have a little less than 10 minutes to get those homework right now. If you do not take advantage of homework time that I give you, I won't give you much homework time in the future.
You did 4. You did 4. 5 and 6. 6.
For today? Yeah, today is 5 and 6. And that's a wrap for this video.
Hello?